Answers to review for quiz 9. Number one and number 2, you're supposed to calculate the average rate of change over the given interval for each function. So pretty straightforward. We need f of 1 minus f of negative 2 over 1 minus negative 2. I plug in 1, we get 11. I plug in negative 2, that's 4 plus 10, which gives me 14. 1 minus a negative 2 gives me 3 on the bottom, so I get a negative 3 over 3. So that means my average rate of change is negative 1. Number 2, same thing. F of pi minus f of 0 over pi minus 0. So we plug in pi, we get sine of 2 pi plus cosine of pi minus sine of 0 plus cosine of 0. So sine of 2 pi is 0, cosine of pi is negative 1, minus sine of 0 is 0, and cosine of 0 is 1. So we end up with negative 1 minus 1 on the top. So we get an average rate of change of negative 2 over pi. 3 through 5, we're looking at the MVT. Remember, in order to use the MVT, we have to be continuous on the closed and differentiable on the open interval. So when I look at number 3, what concerns me about number 3 is I have a variable in the bottom. So I want to know what makes me 0. 0 makes the denominator 0, but if I look at my interval is 2 to 8. 0 is not on that interval, so that means I am continuous on that close. So there are no continuity issues. So then I look at the derivative. Derivative of 10 is 0. Derivative of negative 16 over x would be 16 over x squared. Differentiability issues would be at 0, but again, 0 is not on my interval. So therefore, I am differentiable on the open interval. So continuous on the closed, differentiable on the open. So if MVT can be applied, my next step is to find the average rate of change. So f of 8 minus f of 2 over 8 minus 2. Plug in 8, I get 10 minus 16 over 8. Minus, plug in 2, I get 10 minus 16 over 2. So my 10s are going to cancel each other out. This is negative 2. This is negative 8. It turns into a positive 8. So negative 2 and positive 8 give me 6. 6 divided by 6 gives me an average rate of change of 1. So then once I find that, I set that equal to my derivative and solve. So I'm just going to multiply by x squared and take the square root. Don't forget the plus and the minus. But in this case, negative 4 does not fit in my interval. So my only answer is x equals 4. And remember, we want to make sure we understand what it is we're finding. X equals 4 is the location where the instantaneous rate of change is equal to the average rate of change. Make sure you understand what it is you're finding when you find that C. So this is my C right here. Make sure you understand that. All right. Number 4, no continuity issues. This is a cube root, so it doesn't matter if there's negatives inside. So there are no continuity issues. We are continuous on the closed. If I take the derivative, however, 2/3 inside stays the same. Subtract 1 from the top. Derivative of the inside is 1. Derivative of 4 would be 0. So since I have a negative 1/3, that means this is actually in the denominator, and negative 3 makes me 0. And if you notice, negative 3 is in my interval, so therefore I'm not differentiable at x equals negative 3, and therefore the MVT can't be applied. Number 5, this one, definitely no continuity issues. I take the derivative, definitely no issues with the derivative. So we are continuous on the closed, and we're differentiable on the open. So then I find my average rate of change, f of 3 minus f of 2 over 3 minus 2. Plug in 3, that's going to be 9 minus 9. I plug in 2, that's going to be 6 minus 4. So this is 0, this is 2, but it turns into a negative 2 divided by 1. Average rate of change is negative 2. Set negative 2 equal to my derivative. Subtract the 3, divide by the 2. I get x equals 5/2. Again, 5/2 is my x value where the instantaneous rate of change is equal to the average rate of change. Make sure you understand that. 6, the rate at which water flows out of a pipe in gallons per hour. So gallons per hour right here is my dependent units, is given by the differential function r of time t. So T is going to be my independent, and my independent units are hours, as you see there. The table at the right shows the rate as measured every 3 hours for a 24-hour period. Is there some time T between 0 and 24 such that R prime of T equals 0? So we should identify this as an IROC. So that means in order for that to happen, we have to show that there's an AROC that is also equal to 0. So I look at 0 to 24. And I might need equal signs right there because we're going to use 0 and 24 unless there's something else that matches. Yeah, I need to change that to put equals on there. All right, so it says we are differentiable, so that means we're continuous on the close and we're differentiable on the open. R of 24 minus R of 0 over 24 minus 0. I've got 9.6 minus 9.6, which is 0. So my average rate of change is 0, so the answer is yes, MVT. But I definitely need to modify that and put the equal to on there. Number 7, for the function f prime is given, and f of 2 equals 5. What is the approximation for f of 2.2 found by using the line tangent to the graph of f at x equals 2? So we need a tangent line. Here's my x and my y. So the only thing I need is my slope. So I plug 2 into the derivative to get my slope. So 2 cubed is 8. 8 times 2 is 16. 16 minus 10 gives me 6. So my slope is 6. So y minus the y value equals my slope, x minus the x value. There's my tangent line. Now I want to approximate it for 2.2. So I plug 2.2 in for the x right here. So 2.2 minus 2 is 0.2. 0.2 times 6 is 1.2. I add the 5 over and I get 6.2. So f of 2.2 is approximately the 6.2. Number 8, same thing here, except they went ahead and just gave me this. So this is pretty easy. This is about as easy as it comes. So y minus my y value, my slope, which is given right there, and x minus my x value. Pretty straightforward. There's my tangent line. Approximate negative 5.9. So I plug negative 5.9 in for the x. So that's going to give me 0.1. Negative 7 times 0.1 gives me negative 0.7. I add the 3 over. So 3 plus a negative 0.7 gives me 2.3. So f of negative 5.9 is approximately 2.3. All right, number 9 is slightly different. It gives me the x and the y here. It gives me the instantaneous rate of change at 1. But this time we're going to use it to approximate a 0. So y minus my y value, slope, x minus my x value. But this time, instead of plugging in an x value, we want to approximate a 0. So that means we're going to plug 0 in for y. So I have negative 4 here. Looks like I divided by negative 2. So negative 4 divided by negative 2 gives me 2. I've got the x minus 1. I add the 1 over, and that gives me 3. So x equals 3 is the location of a 0. So that means we're touching where our approximation is that we're touching the x-axis at x equals 3. Now you could have gone ahead and distribute the negative 2 here and then solve. You should get the same answer. 10. The graph of the velocity f of t in feet per second. So feet per second, dependent units of a car traveling on a straight road between 0 and 50 is shown above. Table of values for v of t at 5-second intervals of time t is shown to the right of the graph. Find one approximation for the acceleration of the car in feet per second squared at t equals 40. So we're dealing with feet per second. We want feet per second squared. So I need IROC of this, but there's no way to get that. So we want to approximate IROC with AROC. And we want it at 40. So notice 40 is on my graph, so that means there's 3 different numbers I could use, or 3 different sets. I could do 35 and 40. I could do 40 and 45. I could do 35 and 45. I personally always like to put what I'm trying to get to in the middle. So I chose 35 and 45. So v of 45 minus v of 35 over 45 minus 35. So 60 minus 81 over 10, negative 21 over 10, which is negative 2.1 feet per second squared. Again, as I always say, units are your best friend, so we want to make sure we did our units right. We wanted to get feet per second squared. Notice velocity is in the top, which is feet per second. I have time in the bottom, which is seconds. So if I have feet per second over second, that gives me feet per second squared. So that just double checks that I did that correctly. 11, a test plane flies in a straight line with positive velocity v of t in miles per minute. So miles per minute, there's our dependent units at time t minutes. So minutes would be our independent, where v is a differentiable function of t. Selected values of v of t for 0 to 40 are shown in the table above. Use the data from the table to find an approximation. Misspelled right there. That should say an instead of an. Approximation for v prime of 17 indicates units of measure. This time, 17 is not here, so that means we definitely want to use 15 and 20. So v of 20 minus v of 15 over 20 minus 15. 4.5 minus 7 over 5. 4.5 minus 7 gives me negative 2.5. Negative 2.5 over 5 is negative 1/2. Units on the top would be miles per minute. Units on the bottom would be minutes. So we end up with miles per minute squared. All right, last page, 12. Two chemical substances are mixed together and begin to react, causing the temperature of the mixture to increase. The temperature in degrees Celsius, so degrees Celsius right here is my dependent units, is measured from the time the substances begin to react and is modeled by the differentiable functions P of t, where t is the number of seconds, so seconds is my independent units since the reaction began. Which statement best describes P prime of 45 equals 1.2? So I know I've got to have degrees Celsius over seconds. So I go in and find degrees Celsius over seconds. And it looks like I chose the wrong answer. The answer should be D, because here's my degrees Celsius per second. I don't know why I chose that one. I think I probably just saw increasing and stopped reading. So it should be D. Temperature has increased at a rate of 1.2 degrees Celsius per second over an interval of 45 seconds. Nope, that's not right either. It's going to be C. 1.2 degrees Celsius per second after 45 seconds. Keyword is after. So since it's instantaneous rate of change, it's after. Over an interval means we're dealing with AROC. So my answer here is C. Sorry I screwed that up. But again, units are your best friend. It should have been down to C or D, but over the interval right there was a dead giveaway that's AROC. We wanted IROC. All right, 13, total cost in dollars. So dollars is my dependent to extract X ounces of silver from the mine. So ounces is going to be my independent. Can be modeled by the differentiable function C of X. Which statement best describes C prime? So I'm looking at dollars per ounces. So let's see if I did this one right. So I've got $1 per ounce there. I've got $1 per ounce there. Dollars there. So C is no good. We're talking about 3.5. So that means we need to be increasing. So total cost, that's not it. Total cost, that's not it. Notice I've got increasing. So total cost is increasing at a rate of $3.5 per ounce when the 550th ounce of silver is extracted. So I did that one right. 13 is correct. Last one. The blood pressure of a mouse in a lab experiment is given by the given function, P of t, millimeters of mercury. So millimeters of mercury is my dependent unit, and where the t is the number of minutes, so minutes is my independent. Have lapsed since the experiment began. What is the instantaneous rate of change in blood pressure 3 minutes after the start of the experiment? So instantaneous rate of change, I should be looking for millimeters of mercury per minute. So millimeters of mercury per minute, it's got to be B or D. So this is where we want to use our calculator. Notice it says calculator, so we're going to plug this in on a graph. Then I'm going to add a page. When I get to that add a page, I'm going to get shift minus, which gives me D over D and a blank. Remember, you put X in that blank. I move over to the right. Then I go to variables and I get F1. I put F1 in there. I put X inside of it. Then I get outside of the parentheses. I do control equal. That gives me the vertical bar. I choose the vertical bar. And then to the right of the vertical bar, I'm going to put x equals, in this case, 3. So I put x equals 3, and that should give me 44.031. All right, there it is. Review for quiz 9. Quiz 9 will be tomorrow. And again, as I mentioned earlier, you will get to work on this together. I will be available in the morning, 7:15 in the library. If you need me, please give me a heads up so that I'll know to expect you.